Let's talk about who needs model-based systems engineering in just 5 minutes. In a typical life cycle, we share, we listen, we try to come to an understanding together, and we document that in words. I'm going to call it natural language. And we know that we're not always completely understanding each other, so we apply iterative review throughout a process. The reality is we're always going to be off course to some degree. And as we move further through the life cycle and other roles take that data and add more breakdown to it, in this case requirements breaking down into design specs for instance, we're actually further and further off the mark. Developers add brand new languages, also interpreting the natural language, writing new languages, and it's not until we finally get to the testing phase that we find out that certain systems don't work with others. And worst case is we could go out to the market with a product that still has some flaws in it. The takeaway is that natural language, while useful, has some inherent problems with it. It's easily possible for two different people to look at a paragraph or a sentence and come to different conclusions about what it means. So we need a new language to add to natural language. And that language would be modeling. On the right-hand side, you can see a model here. Notice that the notation is very specific. All these symbols mean something. So for instance, number 4 tells us that there is an either-or choice to something. What are the odds that engineers doing a review of this documentation would find this problem in that gigantic stack of documentation? Probably very low. Whereas if we put this model up in front of the engineers, they could easily spot that this is a problem, and they would all agree about exactly what it says. This is all about objective alignment. Well, modeling is what we want to add together, and this is PTC, our offering in terms of providing all different types of models, and we apply several of those into the process. Context diagrams, requirements modeling, use case diagrams, sequence diagrams. This is not an exhaustive list, but just to give you a sense of what we bring to the table. And of course we integrate it with requirements natural language. What would that look like if we applied it in a life cycle? If we started with modeling and then we elaborated it with requirements, for instance, it might look like this. The model begins here, but then via our integration we bring that into the natural language environment of Lifecycle Manager and elaborate that model. Now we've got the best of both worlds happening. Let's continue through the life cycle. We've got objectivity here and elaboration. Then the analysts do a little bit more modeling, designers as well. We do some more elaboration. We've got a nice combination of those things happening. Then we move to the developers who apply the language that they're native to, but they're doing it based on an objective understanding of the model. We might even be able to generate some code from the model. Now when we move into the testing phase, we're truly going to validate and verify that what we intended to bring to market is what we're actually creating and that it works. Certainly we're going to find defects, but in some cases we'll be able to simply alter the model, regenerate the code, and retest. Worst case is we might regenerate a model, and the developers then look at that objective model and they make a savvy software update. So that at the end of the game here, we've got a benefit for everyone at every part of the life cycle. We're aligned throughout. There's efficient iteration. We keep good designs and we can qualify out bad ones because modeling provides a means of not just visually creating a picture of things, but it's in a live picture and it can be analyzed. Accurate software development is going to be growing up significantly, and of course our testing phase is going to be much more efficient. In the end, the bottom line is that modeling plus natural language elaboration gives us the efficiency and cost and risk savings that we really want. And by the way, modeling does not add work or increase the effort of this process. Modeling dramatically lowers the effort in this process. What we're doing is we're taking the inherent problems with natural language alone and we're replacing it with the efficient objective alignment using modeling. Overall, this is much more efficient and is actually faster for every role involved. There's clear business benefits that have been verified by the EMF survey. Reach out to me if you'd like to get a copy of that. In the end, let's summarize. It depends on what you believe about communication and product lifecycle to answer the question, who needs model-based systems engineering? So what do you believe? If you believe that objective alignment at every stage of product development naturally improves each role's contribution, actually with the least amount of effort, causing a dramatically lower lifecycle cost, risk, and rework, resulting in on-time delivery of a compliant, reliable product. If you believe this, and I think everyone can say that they can, I mean, whether you're Making a simple product, or certainly a more complex product, wouldn't you want to have objective alignment at each step? Of course you would. Well, then the right question might better be put: which products need the value that MBSE brings? Which products need this? And I think you'd probably agree every product really needs that. Model-based systems engineering then makes perfect sense for every product. It gives immediate benefits to each role. It dramatically affects desired business outcomes, of course, and it certainly benefits a startup initiative. In other words, just starting some modeling in a certain part of your architecture would be a valuable thing to do. If you'd like to know more about model-based systems engineering, feel free to reach out to me at jwinder@ptc.com or visit our website, where there's much more detail on what we offer in our products.